Dear students, today we are going to learn some topics from center of gravity. What is center of gravity? It is the point through which the whole weight of the body acts, irrespective of its position. It may be noted that everybody has one and only one center of gravity. Now what is centroid? The plane figures like triangle, quadrilateral, circle etc. have only areas, but no mass. The center of area of such figures is known as centroid. The method of finding out the centroid of a figure is the same as that of finding out the center of gravity of a body.
How to find out center of gravity? The center of gravity of simple figures may be found out from the geometry of the figure as given below. The center of gravity of uniform rod is at its middle point. The center of gravity of a rectangle or a parallelogram is at the point where its diagonals meet each other. It is also a middle point of the length as well as the breadth of the rectangle as shown in figure. The center of gravity of a triangle is at the point where the three medians of the triangle meet as shown in figure. The center of gravity of a trapezium with parallel sides A and B is at a distance of measured from the side B as shown in figure. The center of gravity of a semicircle is at a distance of 4r by 3 pi from its base measured along the vertical radius as shown in figure. The center of gravity of a circular sector making semi-vertical angle is at a distance of 2r by 3 into sine alpha by alpha.
Center of gravity of plane figures. Let x bar and y bar be the coordinates of the center of gravity with respect to some axis of reference, then x bar is equal to a1 x1 plus a2 x2 plus a3 x3 plus so on divided by a1 plus a2 plus a3 so on. And y bar is equal to a1 y1 plus a2 y2 plus a3 y3 plus so on divided by a1 plus a2 plus a3 so on, where a1, a2, a3, etc. are the areas into which the whole figure is divided. x1, x2, x3, etc. are the respective coordinates of the areas a1, a2, a3, etc. on x-axis with respect to same axis of reference. y1, y2, y3, etc. are the respective coordinates of the areas a1, a2, a3, etc. on y-axis with respect to same axis of reference. Now let's do some problems. Example 1. Find the center of gravity of a 100 mm by 150 mm by 30 mm T section. Solution is given here. As the section is symmetrical about y-axis, bisecting the web, therefore its center of gravity will lie on this axis. Split up the section into two rectangles ABCH and DEFG as shown in figure. Let the bottom of the web FE be the axis of reference. First let's consider rectangle ABCH. Area of this rectangle A1 is equal to 100 into 30 is equal to 3000 millimeters square, and Y1 is equal to 150 minus 30 by 2 is equal to 135 millimeters. Next, let's consider rectangle DEFG. Area of this rectangle A2 is equal to 120 into 30 is equal to 3600 millimeters square, and Y2 is equal to 120 by 2 is equal to 60 millimeters. We know that the distance between center of gravity of the section and bottom of the flange FE, y bar is equal to A1 y1 plus A2 y2 by A1 plus A2 is equal to 3000 into 135 plus 3600 into 60 by 3000 plus 3600, which is equal to 94.1 millimeters, which is the answer.
Now let's proceed to the next problem. Example 2. An eye section has the following dimensions in mm units. Bottom flange is equal to 300 by 100. Top flange is equal to 150 by 50. Web is equal to 300 by 50. Determine mathematically the position of center of gravity of the section. Now let's do the problem. Solution is given here. As the section is symmetrical about y-axis, bisecting the web, therefore its center of gravity will lie on this axis. Now split up the section into 3 rectangles as shown in figure. Let bottom of the bottom flange be the axis of reference. For the bottom flange, A1 is equal to 300 into 100 is equal to 30,000 millimeters square, and Y1 is equal to 100 by 2 is equal to 50 millimeters. Next, for the web, A2 is equal to 300 into 50 is equal to 15,000 millimeters square, and Y2 is equal to 100 plus 300 by 2 is equal to 250 millimeters. And lastly, for the top flange, A3 is equal to 150 into 50 is equal to 7,500 millimeters square, and Y3 is equal to 100 plus 300 plus 50 by 2 is equal to 425 millimeters. We know that distance between center of gravity of the section and bottom of the flange, y bar, is equal to A1 y1 plus A2 y2 plus A3 y3 divided by A1 plus A2 plus A3 is equal to 30,000 into 50 plus 15,000 into 250 plus 7,500 into 425 divided by 30,000 plus 15,000 plus 7,500, which is equal to 160.7 millimeters, which is the required answer. Now let's proceed to the next problem. Example 3. Find the centroid of an unequal angle section 100 mm by 80 mm by 20 mm. Now let's do the problem. Solution is given here. As the section is not symmetrical about any axis, therefore we have to find out the values of x bar and y bar for the angle section. Split up the section into 2 rectangles as shown in figure. Let left face of the vertical section and bottom face of the horizontal section be axis of reference. First, for the rectangle 1, A1 is equal to 100 into 20 is equal to 2000 millimeters square. X1 is equal to 20 by 2 is equal to 10 millimeters. And Y1 is equal to 100 by 2 is equal to 50 millimeters. Next, for the rectangle 2, A2 is equal to 80 minus 20 into 20 is equal to 1200 millimeters square. X2 is equal to 20 plus 60 by 2 is equal to 50 millimeters. And Y2 is equal to 20 by 2 is equal to 10 millimeters. We know that distance between center of gravity of the section and in left face, x bar, is equal to A1 x1 plus A2 x2 divided by A1 plus A2 is equal to 2000 into 10 plus 1200 into 50 divided by 2000 plus 1200, which is equal to 25 millimeters. Similarly, distance between center of gravity of the section and bottom face, y bar, is equal to A1 y1 plus A2 y2 divided by A1 plus A2 is equal to 2000 into 50 plus 1200 into 10 divided by 2000 plus 1200, which is equal to 35 millimeters.
Dear students, I hope this video helped you a lot. If you still have any doubts, write in the chat box. If you like this video, press like button, and share this video with your friends. If you haven't subscribed to this channel, press the subscribe button. Press the bell symbol to get continuous notifications of our new videos. See you in our next video. Goodbye.